The discovery of quasars. Quasars were discovered in the 1960s by this man. This is Alan Sandage, and he was a radio astronomer. Now, radio astronomy in the 1960s was very different from the way it is done today. Basically, they pointed radio telescopes at the sky, waited to get a signal, tried to figure out where that signal came from, and then looked for an optical counterpart. Well, Sandage found some objects that did give off a radio signal. And they also gave off a tremendous amount of ultraviolet light as well. But when they looked at photographs of that same part of the sky to try to find the optical counterpart, they looked like stars. And here's an example of one of these objects. And that's actually where the name quasar came from. They're quasi-stellar radio sources. So that got really shortened down to quasars. You'll also sometimes hear them called QSOs, which is for quasi-stellar objects, because they then started finding some that weren't necessarily radio sources, but still quasi-stellar. So we've got these things that look like stars, but give off radiation that stars don't normally give off. And one of the first ones to be discovered, has this very exciting name, 3C273, and here we see it labeled on here. This is actually one of the brighter ones. The fact that it even shows up on this photograph is a pretty good indicator that it's reasonably bright. They took a spectrum of it, and where they saw the lines, they made no sense. Remember that with a spectrum, you're getting spectral lines associated with elements. Well, these lines didn't look like any element anyone had ever seen before. But this dapper guy, Martin Schmidt, actually was the first one to figure it out. He started looking at the lines and measuring distances between the lines. And he started seeing a pattern that looked familiar, and ultimately he figured out what it was he was looking at. It was, in fact, hydrogen, but very red-shifted hydrogen. And that's what the picture up here is showing. These red arrows are showing how far those lines had gotten shifted, and it's hard to get a context here, but that's quite a lot of shifting. Let's see, roughly that much. You're looking at probably about 700 angstroms, which would be about 70 nanometers. That's a big shift. That's not a typical shift. We usually measure shifts of maybe 1 or 2 nanometers for a galaxy. And so here we're getting, hundreds of times more shifted than normal. Using that, of course, the shift gives the velocity. because that's the Doppler shift. And then if you know the velocity, of course you can use Hubble's law. And they found that these were about 3 billion light years away. So, or if you want to think of it the British way, 3,000 million light years away. Up to this time, most known galaxies were at most a couple 100 million light years away. If that. So we're looking at objects that are farther than anything ever seen before. And yet we could take pictures of them. So these things became an enigma. What is it that we're looking at? We found something. We can take pictures of it. We can get a spectrum of it. We can calculate the distance to it. But we have no idea what this is.